One final point to make here in section 15.7 is that the change of variables in 3 dimensions works just as well as change of variables in 2 dimensions. And so now we're going to think that we have a map G going from W0 to W, where variables for W0 are U, V, and W, variables for X are X, Y, and, variables for W are X, Y, and Z. And so then the Jacobian that we would use in this case is now a 3x3 determinant of the appropriate partial derivatives. And so it was just UV going to XY. We'd have a 2x2 determinant like this, but now we have UVW going to XYZ. Now it's a 3x3 determinant. And so everything goes through just as easily as it would before. And to underscore this, what I want us to do is to think about this example here. Suppose that we have a map. Now instead of using UVW, I'm using rho, phi, and theta. If we have a map that is going, X, Y, and Z are written in terms of rho, phi, and theta. And again, let's be clear. This is spherical coordinates. Okay, well, let's carry out the calculation here. Okay, so what do we need? We need dx d rho, dy d rho, and dz d rho. Okay, so these are going to be sine phi cosine theta, sine phi sine theta, and cosine phi. We also need dx, partial derivative x with respect to phi, partial derivative y with respect to phi, partial derivative z with respect to phi. And so what do we end up with here? Rho cosine phi cosine theta, and rho cosine phi sine theta, and negative rho sine phi. And then one more round, the partial derivatives with respect to theta. And so these are going to be negative rho sine phi times sine theta, and rho sine phi cosine theta. And then there's no theta dependence down here, so this partial derivative is 0. Okay, so now let's calculate out the 3x3 determinant. Put those 3 things into our those 9 things into our determinant. So the Jacobian is this 3x3 determinant. Sine phi cosine theta, rho cosine phi cosine theta, negative rho sine phi sine theta, sine phi sine theta, this is a cosine phi down here, rho cosine phi sine theta, negative rho sine phi, and rho sine phi cosine theta, and 0. This might feel like a little bit of a boring problem, a little bit of tedious thing. So let's just take a step back here. What are we trying to do? We're trying to figure out in the spherical coordinates transformation, what's the Jacobian, using the fact that we're doing here a 3x3 determinant, and think for yourself, what is going to be the Jacobian? You should know what the answer is that we're going to come up with. Think to yourself, what is going to be the answer as we come up with it. Okay, 3x3 determinant time. I'm going to, let's see here, it's going to be this times this times this, which is 0, plus this times this times this, that's a rho squared, 2 cosine phi, so cosine phi squared, a sine phi, and cosine squared theta. Okay, then this times this times this, those minus signs cancel out, so plus rho squared, then let's see, sine cubed phi, sine squared theta. Okay, now let's, so 3 terms down of our determinant. Then we're also going to have the negative of this times this times this. So that would be plus rho squared, sine phi squared, or sorry, sine phi cubed, and cosine squared theta. Then this times this times this, that's 0. And minus this times this times this, minus times that is plus rho squared, let's see, cosine squared phi, and sine phi, and sine squared theta. Okay, so this looks like a huge mess. You know, 1, 2, 3, 4 terms, and none of them are looking particularly nice. But let's think about, are there any Pythagorean identities that we can use here? So take a look at this term and this term here. They both have a rho squared sine cube phi, but then one of them has sine squared theta, one of them has cosine squared theta. So the stuff inside the orange box is rho squared sine cubed phi times sine squared theta plus cosine squared theta, that's 1. So the stuff inside the orange box is rho squared sine cubed phi. Okay, now let's take a look at the other 2 non-zero terms. Okay, so what's the commonality here? These both have rho squared, cosine squared phi, and sine phi. So it's going to be plus rho squared, cosine squared phi, sine phi times cosine squared theta plus sine squared theta, that's again 1. So this plus this is equal to this. Okay, now are there any commonalities here? Yes, we can factor out rho squared times sine phi times sine squared phi plus cosine squared phi. So for the 3rd time in this problem, Pythagorean identity says that this plus this is equal to 1. And so we're just left with rho squared sine phi. Did you guess correctly that this was going to be the answer? Just realize this is the thing that I told you that we throw in when we're doing spherical coordinates transformation. So there's a reason. It's not just an arbitrary reason. Back in when we in section 15.6, when we just kind of said throw in the rho squared sine phi. That's the thing to throw in when we're doing spherical coordinates. Well, it's this reason here. The Jacobian is this 3×3 determinant, and when we do 1 and 2 pages of calculations, we do in fact come up with rho squared sine phi. So that's the reason. That's where this comes from.